Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've already seen how the F-test works when we test whether all regresses matter jointly, and we've introduced now the idea that we can use an F-test when we do model comparisons. So the goal for this video is to introduce you to a new F-test formula that allows you to compare two models, like two nested models, and understand every term of this new formula. Recalling from the previous video, we are looking into what we will define from now on as restricted model versus an unrestricted model, where the restricted model was a simple model, while the unrestricted one was a more complex model, usually containing all of the variables of the simple model plus additional variables that we think add more to the variation. In a sense, you can think of this restricted model as a special case of your unrestricted model, and the null hypothesis being that the restrictions are true. Alternative hypotheses otherwise. So by saying that the restrictions are true, it means that the simpler model is sufficient, which means the extra variables don't add any explanatory power. So technically, you're doing a joint hypothesis on these additional variables that make your restricted model complex. You're still using, in this F-test, comparison between comparisons of variations. So if in the basic F-test you compared explained versus unexplained variation, in model comparison now, you're going to compare unexplained variation in the restricted model to unexplained variation in the unrestricted model. So the question will be, did relaxing the restrictions reduce your residual sum of squares enough to justify the extra parameters? So if we formalize this with the formula, the new one being introduced to you now is the residual sum of squares from the restricted model minus the residual sum of squares from the unrestricted model divided by Q, then residual sum of errors divided by N minus K minus 1. And in the K in here, I'm going to add that I am referring to the K of the unrestricted model, just so that you don't forget. So let's look at all of these elements and see where they are coming from. So for the RSS, we have now seen where to find it in a data output. We know the intuition behind it. It's just that when we're looking at this RSS of the restricted model, we're just looking at the regression output of the restricted model. So we're taking it directly from there. While for the RSS of the unrestricted model, that means that we're going to run this other model and get that information from that particular model. This Q is the number of restrictions. This is usually going to be seen directly in your null hypothesis. So if in your null hypothesis, for instance, you had that beta 2 is equal to 0 and beta 3 is equal to 0 and let's say beta 5 is equal to 0, that means that your Q is equal to 3 because you are looking at 3 betas in here, whether they are jointly statistically significant or not. If instead you had that the H0 is just beta 2 equal to 0 and beta 3 is equal to 0, that means that your Q is simply equal to 2. Getting back to the other elements, N is as usual your sample size, which should be equal for both of them if you're really comparing models. So if you're comparing models where your number of observations is different, then you have to be very careful, because it might mean that the comparison that you're making is not exactly between apples and apples, but apples and oranges, because now you have to take into consideration if anything changes, given that your observations are not the same in both regressions. Then the final element we're gonna concentrate on is the K. So the K is coming from the unrestricted model, meaning all variables, so all number of variables from the longest or complex model. Okay? The key intuition here is that the numerator, as you can see right here, given that it has this difference between the RSS of these two models, it's literally measuring how much the residual sum of square falls when you basically relax restrictions. This test statistic is going to again have a F distribution, and the degrees of freedom will be the Q for the first one and N minus K minus 1 for the second one. So as you can see, very similar to the F-test that we've been conducting so far, and it's very easy to figure out what the degrees of freedom are, because you just need to look at numerator and denominator separately and see what they are divided by. The decision rule will still stay the same. So whenever you see a large F, especially larger than the given F critical value that you have, you will reject the restricted model. So once again, now you have been introduced to a new formula, but this is for model comparison, and the F-test checks whether relaxing the restrictions reduces your RSS enough to explain or justify a more complex model. In the next video, we'll work through a complete numerical example, so stay tuned and I will see you then.